So yeah, so all right, people, what is density by definition? Mass over volume. All right, so what if I told you I had like a piece of plywood that is, I don't know, whatever. Let's just say it's a piece of plywood. So it's like a uniform, this is a constant thickness. So here it is. Is it cardboard? It doesn't matter. It's just a constant thickness, yo. Just relax. Okay? So the volume of this sucker would be really its area times this constant thickness, yes? Huh? Hmm? And you're like, wait a minute, so Mr. Graham, mass would then be equal to rho, which is density, times volume. That's true. That is true. Well, that seems easy enough. It is. It is easy enough. So then, well, So suppose I had a function that looked like this. Hypothetically. Okay? If you had a function that looked like that, how would you go about finding the area under that curve, if you will? How would you go about finding it? Well, I would find the integral, that's right, of this f of x function from a to b, right? And then I would times it by its constant thickness, yes? That's basically what it would boil down to, because it's two-dimensional times one, times that piece right there, and you'd be home free. Yes? And that's fine, and that's great, and that's wonderful. But that would be the area, and then if you times this whole, so this would be the volume then, I should say, volume times density. Nice. 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 Now, what if something had, so if we say it had homogeneous density, that is, it does not changing, then this is just another constant, yes? But what if the density changed? Ooh, that's a good trick. Meaning, it was really dense on this end, and as you went this direction, it got less dense, maybe, I don't know. So you're saying that density might be a function of x itself. Yeah, it could be. It could be. Well, that would get messier. Yeah, a little bit, yeah. So we're going to look at that a little bit. Okay? But for the most part, we're going to do constants, but we'll do a few of the other ones too, just for a good time. And then I know what you're thinking, because Brooke goes, Mr. Grimm, the other day I saw this piece of plywood in the shop, and it was literally built like this. And I picked it up, and I put my finger right there, and it balanced. Dude, that's hot. And we call that the center of mass. And we know it sits there because, Brooke, here's the dealio. There's a torque in this direction and a torque in this direction, and they balance out. There's a torque in this direction and a torque in this direction, and they also balance out. And it just sits there, and you're like, oh, that's so key. So can we find out where that place is? Yes, and we are going to today. Okay? So a couple of things we're going to look at today, and they are as follows. For instance, we will look about the x center of mass is the way your book writes it. I don't care for the way they use it, XSCM, but I'll write the way they do just because you don't get confused. So this is the moment about the y-axis. You're going to learn about that in a few minutes, okay? Over the mass. And the y center of mass is the moment about x over over the mass. Right? Yay! It's also this way. This is the moment about x-axis. That's cool. Why is it that way, Mr. Kroon? Well, here, look. Y goes this direction, right? Y is this direction, right? And so the x-axis is through here, and the idea is that is, if you will, the fulcrum kind of a dealio going that way. That's why it's that way for y. And then this way, it's the moment this direction about the y-axis. That's why it's on the x. So balance it out that way. So we'll look at those. And you're like, well, screw 'em. Mass is it's straightforward. I mean, it's just literally it's rho, and then it's basically rho times that, again, that constant thickness times f of x dx. This is basically your mass. That is, again, assuming uniform density. Okay? That's easy. Okay, so then the only question is, how do we go about finding these guys? That's the tricky part. Okay? And yes, for this, you will be allowed to have a note card for this piece. Or I might write on the board. I'm just a nice guy like that. I don't know. I haven't decided yet. Okay? Now, so the moment about the y is equal to this formula right here. It's the density. And then from A to B, x your book writes it like this way, which I find a little obnoxious. But there it is. Okay? Now, what are you saying about that? Well, what I'm saying is this, is that if you have two functions like this, where this is f1 and this is f2, you could literally find the balancing point for this guy as well. Okay? But another way of saying it is you take this guy minus this guy here. It's just the y value subtracted from one another. Yes, exactly like you would if you're finding an area. That's it. Dx, of course. And the moment about the y, the x-axis rather, is a little trickier. And some of you will hate this, and I don't blame you, as I don't like it either. And it goes like this. So there's a couple ways to do it. But this is the one that your book shows, so I'll go with it. Rho. And it's C to D, and then it's y, g of y minus g2 of y, okay, dy. So that's one way to write it. However, notice what's happening here. These are functions of x's, yes? These are functions of y. Well, that sucks. What if this function was like x cubed plus 3 ln of x? Well, then you'd be out of luck is what you'd be, friend. So there's got to be another way. So there are two. And I will show them both ways to you because most people, well, if you're smart, you'll like it this way. Is it 1/2? I always forget that. It's 1/2. Sorry, it's 1/2. And it's, yeah, f of x. These two go together if you have functions of x. These guys go together if you have functions of y. Did I screw something up?
I have a question.
Yeah. I will in a minute, yeah.
I'll just come up there.
Yeah. So what I want to say is this. These two, if you have functions of x, which we have here, you will use this pair here, yes? Lacey, if you have functions of y here, you'll use this set here. They're the same. What's up, bro?
That's what I got for that one.
Shut up. 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 Freaking. No, you did it wrong.
I did it wrong.
Did you draw the picture?
I did. I have it on Desmos. You want to see it?
No, look, bro. It's here. It's no. Stop. It's here and it's there.
Yeah.
So what are your y x's bounded by? Bounded by this guy and this guy, and your y's are bounded by 0 and that. Yes.
Mm-hmm.
Why would you do it in two pieces like that? That's weird.
Well, if you're doing it for y, then you need to
Just
do it.
I know, but
do it by two pieces.
Well, you would if you're doing the y version.
That is the y version.
You still schmucked it up. Oh, for God's sakes. You did, because I put... I changed that font. God damn it. All right, I got number... What is that number? Which one?
2.
Number 2 and 3. Make that y equals 1 right here. No, it doesn't change much at all. Judas Priest, except it actually works. I changed the function after I put the... I thought, those are cool bounds. And then I changed the function. Should have left it alone.
Oh, so you want it like y equals 1?
Just scoot it up.
Okay.
Now we should be good to go.
Okay.
Okay, in theory.
I mean, we'll see.
Okay. So,
I'll decide.
So screw, I want to know where to balance this function right here, okay? Let's go on Desmos because I want to see a cool picture. There we go. So x minus x squared plus 4. There we go. Cool. Nice. 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 So I'd like to know if you were just going to chop it off there and here, y equals 0, this little region in there, I would like to know where would my center of mass be? Where would I need to put my thinner to balance that thing? Okay? Now, take me a wild stab. Give me an x and y, approximately where it would be. Oh, I don't know. Height. I don't know. Height looks like to be, I don't know. Let's look. I don't know. 4-ish? Yeah, I think it's 4-ish. Yeah, that doesn't count. Yeah. It's 4. It's exactly 4. Yeah. Yeah. So, but I feel like, did it work this time?
Well, okay, so the 2-part one, I got one for like the right part, but then on the left part, it's been busy for about the last 30 seconds. And at the bottom left, it says questionable accuracy. It just popped up after like 45 seconds of being busy. It was like, okay, you know what? Questionable accuracy.
Okay, well, whatever. Get it set up. I don't care. So listen, so about 1-ish maybe on the x-axis. Do you buy that? Yeah. 1-ish on the x-axis, right? And how far up would you go about, Lace, to balance that? 2-ish? So you'd be shocked if it wasn't somewhere around 1-ish, 2-ish, yes? I feel like I would be too, dear. So let's look at this fella. And what was the equation? It was negative, it was x minus x squared plus pho. Is that right? I think it was that. I think it was, sure. And let's get again on the region 0 to where?
0 to
2.562. And let's just say that the density here is 3. So what we need to do, of course, is we need for our x center of mass needs to be the moment about y over its mass, and the y center of mass needs to be the moment about x over its mass, over the mass, I should say. Well, first things first, you probably got to find the mass. So the mass would be this. So again, this thing right here, okay? So when we do this problem, we're working it out like so. It's going to be x minus x squared plus 4. Technically, you're like, well, not really the mass. Well, I'd had to tell you. I would have told you this thing right here includes the thickness portion of it. Okay? So in other words, I maybe have already multiplied it through by a thickness, if you will. Okay? And so I'm going to get from where, as I say, 0 to 2.562. So it's going to be x squared over 2 minus x cubed over 3 plus 4x, 0 to 2.562 times the answer by 3. This is our mass. What does that come out to be? I don't know. Bless you. Let's bust it out, yo. Oops. Did it come out, Levi, as an answer yet?
Yeah.
Good.
I'm checking it on the other.
Oh, it came out all good.
They work both ways?
Yeah.
Good. God, that's embarrassing. I totally went back and changed that problem, too. It's like, oh, I like this one. This sounds interesting.
23.77.
23.77. Cool. 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 So for the moment about y, the function is what? Well, remember we just wrote up there a minute ago. It is rho, and then it's x times the difference in the two f of x's. But we only have one f of x, right? Well, technically we have two of them. We've got this guy and we've got f of x equals 0, yes? Right? Because in other words, it's down to the x-axis. So this guy minus this guy is just the original fella, yes? So it's x times from 0 to 2.562. So our row is what? We said it was 3. So this is x squared minus x cubed plus 4x dx. Now let's go to integrating. Mm-hmm.
Did I plug something in wrong? Because this answer looks way too big.
No, yeah, you look goofy. Did you draw the picture of this quadrant, what it looks like?
Yeah.
What does it look like? Let me see a picture. What's up?
You want this slice?
Yes.
Or that's this slice?
It's between the y-axis.
Oh, yeah, that's for that part. Okay.
So that piece up in there, bro.
Okay. Okay.
Yeah, your bounds are weird on your theta. What'd you get for an answer?
43.889.
Right. No. What do you notice? Does that seem reasonable? It feels pretty cool to me. I like it. I like it a lot. Now, let's do the other one then. So then the moment about the x-axis needs to be, and again, I always have to look this one up because this one always just bugs me and I don't know why. But it's this right here. So it's f of x, which we said was x minus x squared plus 4, right? Squared. 0 to 2.56. 2, or whatever I said. So it's 3/2. Any idiot can do that. And so this, of course, is going to be x squared. I can't do that in my head. Well, I could, but I don't want to. I feel like I'd be showing off, and that would be sad. So it's going to be x squared, and then minus x cubicled plus 4x. And it's going to be minus x cubed, and then it's going to be plus x to the 4 minus 4x squared. And it's going to be plus 4x minus 4x squared plus 16. And so in Levi order, x to the 4 minus 2x cubicled and then negative 7x squared and plus 8x plus 16. Still haven't integrated yet. Just making it so that I can. So x to the 5 over 5 minus 2 x to the 4 over 4 minus 7 x cubed over 3 plus 4x squared 16x from 0 to 2.562 times the whole shooting match by 1.5. The worst part about these problems is when you make a mistake partway through and you get done and you're like, oh. Remember we said the answer should be somewhere around 1 and 2 or something, right? Right? So the 1 worked out nicely. This answer better come out to be about 46-ish.
42.8.
BAM! 42. Who is this person? Why is she here? Remind me of her name. Wait. Stop. Wait. Why do you all hate me so much? I know. Wow. Anyway, what does this come out to be? 1.8? 1.801. Nice. So we thought it should have been 42 point something. So what did we say it was 1.005 or something? Comma. Right there. Oh. just about where we thought it ought to be, huh? Huh? And if it's nice and uniform density, does it matter where we put it exactly? I mean, doesn't. I mean, we're just like, oh, it's right here somewhere. I mean, it's about where it looks like it ought to be. Now, we are going to have a little bit of a demo one of these days where I give you something, or I ask you to do it. I'm not sure yet. Probably going to ask that you do it. Probably with a piece of poster board or something, or cardboard. Probably with cardboard. Does it really matter what the density is? No, because I feel like it divides out anyways, doesn't it? Check it out, dog. Go back to the dead over here. This density business here had a row in it, didn't it? This guy on top had a row in it too. Ching, ching. It cancels out anyway, as long as it is uniform. Yeah. So like a piece of cardboard, it would cancel out. It wouldn't make any difference. So it'd be fine to go. If it was something where it got progressively lighter or heavier, that would be an issue, obviously. Okay, so at this class, at this level, the nice thing is, for the most part, we're going to use uniform density. But when you get to Calc 4 stuff, although we're not going to do it with you guys, but we could, their stuff could have it could change density in the x and the y direction. Awesome. Yes. So we won't be doing any of the really nasty ones in this class. 251. It's really just a matter of looking at it, going, oh yeah, cool, let's do that. Okay. Ooh, here we go. Oh, by the way, another name for center of mass, centroid. Just so I mentioned, I forgot to mention your book uses it. So just so we're clear on that. Okay. Here is one. Ooh, yes, here we go. So ln of x and then x minus 1. I feel like we should graph that. ln x, oops, and x minus 1, and from 1 to 3. That's convenient. Oh, friends. That little region in there is where I'd like to find the center of mass of, yes? This little region in here. Now, clearly, it's going to be somewhere around x equals, what, 2.5-ish? Yes? Right? That's going to be the center of this location in here. You see it? In here somewhere? Yes? Yes? Right. Somewhere in that neighborhood, though. Right? And then y is going to be somewhere in this ballpark in here, yes? Ish. If I had to guess. Right? So what does that say? What is it? I can't read that. So about 1 1/4. About a y of 1 1/4. About a 2.5 on the x. Yes? So when we're done with this in a minute, keep that in mind. That's what we should be looking for. Okay? Now, let's go look at it. So our equations were ln of x. And what was the other one? X minus 1? X minus 1?
Yes.
Who's on top of whom? Oh, I don't know. That's why we graph it. X minus 1's on top, yes? So our new what just happened here? So our new function is going to be x minus 1 minus ln of x, right? Because that's the lower function. This is like our new function. From here on out, we're good to go. All it wants is the centroid. Notice, this is a big freaking deal. It does not give us the density on this problem. Oh man, whatever shall we do? Well, keep in mind then that this function for this guy here just becomes what? Just becomes the integral from a to b of this new function, right? And divided by the mass, which just becomes basically the area function, right? Oops. Ah! What is wrong with you? The new function. Ah, dang it, something's goofy. What did I write down funny? Now, the mass, we get the density times that, and we get to find the length of that. And so, why does it look funny? Oh, because I forgot the x down here. That's why. There, I forgot. There's an x right there. I almost forgot that part. It would be a problem otherwise, wouldn't it? Wouldn't it? Because it'd be the same function. It'd be like 1 over 1, and that's not bueno. Okay. So let's try it. So we know that it's going to be x times x minus 1 minus ln x dx. And from where to where? From 1 to 3. And then on the bottom, it's just from 1 to 3 of x minus 1 minus ln of x dx. Oh, this one's gross. Yep, it sure is. So x squared minus x ln of x. Ugh. You know what I'm tempted to do? I'm tempted to show you how to do this on the calculator, but I'm not going to. I'm tempted, but I ain't gonna. All right, so let's do the top. So clearly this is x cubed over 3 minus x squared over 2. Yuck. If you had x ln of x, what do you do? How do you take the integral of that? You let u equal ln of x, because it's literally Liotte. Right? So you're going to get x squared over 2 ln of x plus minus, well, half of an x dx. So it should look something like that.
You have to be bold, number 4.
Yes, I want you to use bold.
You have to be bold.
Yeah. Extra credit if you do it both ways, and they match. Yes, you should have watched the video, losers.
Oh, that's right. That's right.
Okay, punch that in. That should work for us.
So this
Oh,
one.
I can't read that.
Yeah, that's hard to see back here.
What am I doing?
Well, that's what my equation was, but
Mhm.
my answer.
So for which one? The polar one?
Yeah, for number 4.
Really?
Here, let me grab my worksheet back.
No, stop. I see the problem. You put times right there.
Oh, that's probably why.
Mm-hmm.
Okay. Yeah.
What do you get? What do you get for an answer on top? What do you get? What do you get? What do you get? Yes, dear.
Where on the bottom did the plus x come from?
Well, Mr. Groom knows, but I could show it using integration by parts, that the ln of x is x ln of x minus x. And then you notice it was minus already, dear? So I just multiplied the negative through. I was trying to speed things along a little bit. I probably shouldn't have, because I'm a horrible person. This bit? What do we get for an answer there? Anybody got an answer for me? Who's got an answer?
That is not a good one. But I mean, it's like.
Yo, the y-axis, dog. That's up in here. Seriously, that's two of you that blew the y-axis. You can. Like, kind of use the bullet form, but.
Hey, hey, you remember the video? The polar video? I was so excited because I thought you gave us like one of the problems that was on the video.
Is it? Oh, okay. What'd you get for an answer? Do we got an answer yet? Do I have to do all the work myself? Probably. It would probably be faster, Mr. Groom, if you just did it yourself. I never want to open the email from Reed during class, in front of the class, because you never know what he's, well, that's not true. Frequently you know what he's going to say, but you don't want to show it in front of the kids, because then they'll be like, you'll never guess what Reed said. Oh, it's too late now, brah. Wait, what just happened on top there? Mr. Groom, you idiot. You know what's missing right here? The ln part, you idiot. All right, let's try this again. So, of course, Mr. Grimm actually caught himself that time, sort of.
On top because I didn't.
Times the ln of x plus 0.25 x squared. Oops, such that. What? Oh, yeah. What?
It's kind of gnarly.
That's gnarly. Oh, that's all right. Such that x equals 3 and such that x equals 1. And so grab this guy minus this guy and you get 1.722. You see that? On top? That's what I got on top? Well, we'll find out. One of us is wrong, pal. I don't know. I just work here. I wouldn't bet on me. You hippie. .704. Guess we'll find out momentarily, yo. I got 2.44. Hey, wait a minute, Mr. Chrome. Isn't that what we said it should look like on Desmos? Didn't we say 2.5-ish? Well, it feels pretty good to me. You know what I'm saying? It feels good. Since it feels good, I'm going to go ahead and do that. X equals, what did I say, 2.44? What? Now let's go find a y. All right, so the y's are a little grosser. They always are. Now notice the denominator is going to be the same. So the moment about the x is going to look like this. It's a half, right, times rho, which we don't know, so it's just 1. That's totes fine. And then it's our function squared. Yuck. So a half. And we're going from 1 to 3. And our function was, what was it? X minus 1 minus ln x. Ugh. That is just gross. Oh, I don't want to do that by hand. Oh, just shut up and do it, you big wuss. But it's so gross, Mr. Grimm. God, you're an idiot. X squared minus x ln of x. Yuck. Minus x plus 1 plus ln of x. And then I'm going to get minus x ln of x plus ln of x plus ln of x squared. So that's x squared minus 2x plus 1 minus 2x ln x plus ln of x. What is this crap? Is that another plus ln of x? It is, huh? So there's 2 of them. And then plus an ln of x. Squared. Oh, that's gross. That's just sick, dude. Okay, let's go to integrating. Okay, so that's x cubed over 3. X squared plus x. I don't want to. Can we not? Alright, let's quit your whining and just do it, you big wuss. If you have x ln of x, then u is ln of x, du is equal to 1 over x dx, right? Then dv is equal to x dx, and v is equal to x. Oh, we just did this one a minute ago, didn't we? Oh, then what's the frickin' answer? Wasn't it x squared over 2 ln x minus 1/4 x squared. Okay? And so it's times by negative 2, right? So it's going to be negative x squared ln x plus x squared over 2. Okay, so that's that part right there. Yuck. 2 ln x is going to be plus 2, and it's going to be x ln x minus x. I know that one. So then all I have left to do is that last one, that ln of x squared. And I'm going to cheat and look it up because I don't care. No, I'm not going to. I'm just going to do it on my calculator. What do you got? What do you need?
I got a negative number for this one.
That. No, you didn't. So, no, you shouldn't have. How about that?
Okay.
You shouldn't have, I don't think. There. Ah! So it's x ln of x squared.
I can read off.
All right. Go ahead.
Minus 2x over x. Minus plus 2x plus 2x.
And you went ahead and you multiplied the 2 all the way through, right?
X, yeah.
Good. The x, I mean, yeah. All right, so there it is. That's gross. Who cares? Whatever. And we want to evaluate this from 1 to 3. So, you know, whatever. There's 2x ln of x is here, and there's a 2x right here. So if you clean this up a little bit, some of this crap might cancel out. Oh, look. No, I lied. Yeah, I don't care anymore. I'm just going to just punch it in. I'm too lazy. Are there going to be a lot of hard ones like this on the test, on the homework and stuff? No, the homework's pretty straightforward, I think. I don't know. I haven't done the homework, so I could. What's up? Plus x times parentheses x. Oh, you hippie. Yep, there's that one. And this one. So you grab this dude. Minus, no. Oh! Ah, whatever. I hate you too. Piece of crap. Minus this guy. I get 0.2-ish. What was our bottom answer? 0.7. What do you get for an answer here? It's wrong, clearly. What is it going to be? What is it? What is it? Do it now! What's up?
Yeah, so on this one, graph it. Almost like that.
Yep.
Oh, that.
Right. Still that region in there. Oh, no, but it's not x equals 1. It's still y equals 1.
It's still y equals 1?
Yeah. You can't change that. There you go. Yeah, it's in that region in there.
That,
Yeah.
okay.
What did you get for an answer?
1285.
0.285. Oh, Zach. Zach, I think we're wrong, bro. I feel like 0.285 is clear down in here somewhere. I feel like that's weird. No, it's way down there. Oh my gosh, Mr. Grimm, I think we messed up. I think we did too. So now, where do we go wrong? Probably in the integrals. So, I'm trying to do too much at one time. So, we will be using some calculators the next day or two. I'm going to go ahead and integrate this time just for fun this way. And so it was parentheses, it was x minus 1, right? Minus the ln of x. I will show you how to do this in the next day or 3. Oops. To the second power, comma x, comma 1, comma 3. I hate you too. 0.4-ish, 0.4-ish, 4-ish. Something's still screwy. What?
That's at least one.
Well, that's part of our issue, but that's not all of it. Something feels like something's a little weird there. Oh! Actually, I was right the first time now. What did I forget to do? Didn't divide by 2 because it's times by half. So I'm still right. That's weird because that means I integrated right. Good news, bad news. You integrated right, Mr. Groom. Bad news is we are still screwed. Okay. Now, where are you going wrong, Mr. Groom? So, friends. What did I say? This 0.285 right here? Yes? That's what I said? Does that seem weird to you? It does seem weird to me, but only because this. Mr. Olson, if I did this, x minus 1, right, minus ln of x, I get this number down in here, which is this green fella. Now, oops. Why aren't you graphing me? Oh, it's over here. Right. There it is. Sure. What is 0.285? What did I say it was? 0.285? What does that look like to you? It feels like 0.285 right about there. Wait a minute. That's coming up from 0, yes? But what would that look like on a regular graph, friends? Well, I feel like this is the bottom of our... Hide the green one. It's freaking me out. The orange line is the bottom of our new REIT right here, yes? And if you click on it, what do you get? Why, you get 0.892. And I wonder, I mean, hypothetically, I wonder what 2.44, comma, oh crap, what did I say that was? 0.892. But what is 0.892 plus our whatever we just got a minute ago? Plus our 0.2 or whatever I got, 0.285, whatever. What was it? It was 0.285, wasn't it?
1177.
Oh, does that look like it might be reasonable? Yeah. See, that's a tricky one. And honest to God, I was not playing for a second. It kind of had me for a second, like, uh-oh. Oh! But remember, when you do the subtraction bit, the shape that you're finding is not this goofy pie-shapey looking one, right? It's actually this fella. Oops, not leave that alone. It's actually this guy down in here. And if you think about it, right there should be a point that is 2.44, comma, 0.285, yes? What? And then, so over that where did the 3 go? Oh, I shut it off. There you go. So over that region, does it look like right there you could balance that green-shaped region down there? I feel like that's true. So that is a tricky deal right there. Please don't do that, what I just did, because I actually was legitimately scared for a second. I legitimately was. I was panicky a little bit. All right? The Y ones you will mess up from time to time, simply because you'll talk yourself out of them. Don't turn in an assignment unless you figure it out. I mean, look, seriously, if the thing was -5 was where... No, you're wrong. I'm going to bounce over here at 7. No, you're not. Dang it, it's only going to 3. That's weird. Okay? If it was clearing this corner over here, no, that's not right. That's stupid. So, legitimately, when you first look at these guys, you should be able to kind of look at it and go, oh, yeah, it sounds about reasonable. What time is this class over? 2 minutes? How many minutes? Say it. 4 minutes? For you legit.
Are you legit?
Okay. Too legit to quit. All right, that's enough. All right. Okay, so that is on page 486, I guess, is the stuff that you should be working on this evening. And come with questions tomorrow. We're going to do a little bit more